Hello, dear students. Hope you are doing good. Today we'll start Cambridge 2025, October, November, variant 42. In the last video, you have seen 41. If you have any question, you can ask in the comments. So let's start this paper. Question number one. Question number one is state the difference between scalar and vector quantities. This is 1 mark. So you can just explain about the definition, like vectors have direction and magnitude, scalar have magnitudes only. So you can just write vector have magnitude and direction. So you will get 1 mark. Question two. In the list below, draw the lines under the each of the following is a scalar quantity. So scalar quantities, let's revise it. What? Which have only magnitude. So if you see the first one, this is acceleration. This is vector quantity because rate of change of velocity. Velocity is vector, so acceleration is vector quantity. Second one is mass. Yes, mass is a scalar quantity. Momentum. What is momentum? Mass time velocity. So momentum is a vector quantity. So no need to write cross. Electric field strength. Electric field strength is a vector quantity. Energy and temperature. So there are three scalar quantity in this. So if you just write twos, you will get 2 marks. Okay. Part B, question 1B, a tennis player throw a tennis ball into the air. The mass of the tennis ball is 5.8 times 10 power minus 2. The tennis ball leave the tennis player's hand, reach the maximum height. So we have the mass. I'm just writing symbols. We have maximum height. I'll show the initial velocity is 9.9 meters per second. So we have to prove this answer. So if we see, we have mass, we have height, and we can find energy. So what is this? This is mgh, gravitational potential energy. We will use gravitational potential energy equation to find gravitational potential energy because energy is conserved. So kinetic energy at some point is equal to gravitational potential energy. Then we will find velocity by using the equation of kinetic energy. So first, I'm just writing the equation. Gravitational potential energy is equal to mgh. Okay. And second, we will find velocity. So we know that kinetic energy is equal to 1 over 2 times mass times square of velocity. And from here, we can find velocity like 2 times kinetic energy times, divide by m, and we will take the square root of it because velocity is a square, so we will take the square root on both sides. Okay, first we will find gravitational potential energy. So I'm just writing EP. Okay, m is 5.8 times 10 power minus 2. G is 9.8. I'm just writing 10 times 5. You will write 9.8, by the way. I'm just writing 10. So here I will have gravitational potential energy, which will be equal to 10, 5.8. I have to use calculator. So it will be equal to some. Um, okay, times 5. So gravitational potential energy will be equal to 5.8 times 5 times 10 minus 1. So it will be divided by 10, divided by 10. So it will be 2.9 joule, which is equal to kinetic energy. So we can put kinetic energy is equal to gravitational potential energy. So V is equal to 2 times 2.9 divided by mass. That is 5.8 times 10 power minus 2. And there is a square root on it. So we'll get 9.9 meters per second. This is first method. In the second method, you can just equate both energies, which is kinetic energy is equal to gravitational potential energy. So we can put the values like kinetic energy is equal to 1 over 2 mv square because mass is constant in both sides. So mgh. So m will be cancelled. So v is equal to 2 will be multiply on this side. This is the easy way you can solve by using this. And by putting the values 2 times 9.8 times 5, you will get 9.9. I think the red one is easy way. So you can solve by using this method. Calculate momentum of tennis ball as it leaves the tennis player's hand. So what is the equation of momentum? Equation of momentum is, first of all, momentum is equal to P. P is equal to mass times velocity. What was mass? Uh, Mass is here. Yeah, 5.8 times 10 power minus 2. And V was here 9.9 meters per second. So we can write here 9.9 meters per second. So here we will have momentum that is 0.57. By the way, momentum is a vector quantity. So we have to write the direction of it. So when the velocity, obviously the ball is moving upward, so it is the direction in the direction of velocity that will be upward. There is no unit, so you have to write the unit as well. So I'm writing unit here, that is Newton second or kilogram meter per second. So you can write both units. Question number 2. A truck moved with a constant acceleration. The speed of the truck increased 13 meter per second to 22 meters per second. So speed is changed 13 to 22. Okay. So the time taken for increase, this is time, this is speed, finals, this is initial speed, this is final speed. Okay, that mass of the truck is 3,700 kg. So calculate the resultant force. So whenever you calculate the resultant force, like 90% you will use F is equal to ma. We have mass and we have the data of acceleration. So we can find the acceleration by using change in velocity over time. Okay, what is velocity? How much velocity is changed? 22 minus 13 divided by time is 4.5, right? So whenever you calculate the acceleration, that will be 2 meters per second square. Now you can put the data. 3,700 times 2, and that will give you the answer of force, that is 7,400. What is unit? Unit is Newton or kilogram meter per second square. But I will prefer the SI unit, that is Newton. Part 2, the engine of the truck provides the forward force. State two forces acting on the truck in the opposite direction in the forward force. So when the truck is moving forward, there is opposite force, that is drag force or air resistance. And the second force, you can say that the friction between tires and the roads. So first you will write air resistance or drag force. I'm just writing air resistance. The second point, you have to get 2 marks. So friction. Just write friction, or you can explain it between tires and road. B part. Figure 2.1. Show a car as it travels in the round circle direction of movement of car. So this is velocity and this is circular track. a car is moving towards P point, the car is moving with constant speed. We cannot say that the car is moving with constant velocity because the direction of car is changing at every point. So speed is constant. On the figure 2.1, draw an arrow to show the direction of force. So whenever an object moves in the circular track, there is a force which is always act towards the center of the circle, that is called centripetal force. So you will mention the arrow towards the center of the circle. Second part, a different car travel around the same track, slides off the track at point P. State two possible reasons that cause the car to slides off the track. So if the car is moving in the circular path, so what is the possibility to slide off? Car is moving with high speed. There is a less friction between tires. Tires are not good. And if the car is heavier. So if you can say that the difference between the bus and car, bus cannot travel in the circular path with the high speed. So you can write high speed first. The second, you can mention friction between tires and roads, or you can just mention the tires are not in good quality. The third, you can mention large mass. That is also a possibility. So this is question number 2. Let's continue question number 3. Figure 3.1 show black solar panel is installed on the roof because of house and large rechargeable battery. So electricity can be stored. Okay, these are solar panel, black colors. These are electric cables, large rechargeable battery. So this is battery which is making voltage as well. So this battery is used as input and output as well. So the solar panel produce electricity, give maximum output. So this is output power at the efficiency. This is efficiency, which can be written as 0.16 because 16% is 16 divided by 100. State and explain one advantage of using black solar panel. We know that black is a good absorber, right? So black is good absorber. So what it's mean? It's mean more electricity is generate. Okay. So because of black color, it absorb the heat, so it produce more electricity. Calculate the power received. So we have to calculate input power by the solar panel. So if we take the data from the questions, output power is equal to 3.5 kilowatt. Okay, efficiency is equal to 0.16 because 16%. We need to calculate input power. So if I write the equation, efficiency is always equal to output power, useful, that is, and divided by input power. So when we convert or rearrange this equation, so input power will be equal to output power divided by efficiency. So what is input power? Output power, sorry, 3.5 kilo. So I will not change kilo because output power will be, the answer will be in kilo as well. 0.16. Okay. And uh, after using calculator, you will get 22. So the answer will be 22 because I did not change kilo. So I will write with the answer. The answer is in kilo, kilowatt, because there is no unit of efficiency. So it will be kilowatt. The solar panel produce direct current and household appliances using alternating current. State the difference between alternating current and direct current. In the house electricity, we use alternating current. Alter mean change. Direct mean no change. So you can just write alternating current. Alternating current change its direction and you can write direct current, or you can just write DC, alternating current AC, or direct current DC, direction, sorry, flow in one direction. Or you can write in your own words. D part suggests one advantage of storing energy in the large rechargeable batteries. What is the purpose of the battery? So we can, when in the dark, when at night, in the cloudy weather, in dark, electricity is usable. This is the purpose of batteries. Calculate the charge. Charge mean Q. That flow, there is current. Current is 4 ampere. So this is I. And 2 hours. So this is T. And make sure time should be in seconds in this equation. So Q is equal to I times T. This is the equation of current and charge. So I is 4. T is 2 hours. So 60 minutes times 60 seconds. So the answer will be 29,000. You can write SI unit or you can write base unit. If you write base unit, that is ampere second. If you write SI unit, that is coulombs. Okay. Question number 4. Figure 4.1. Show gas trapped in the cylinder. In this region, the gas particles are trapped because of this sealed piston. The volume of the gas is 240 cubic centimeter. The piston is pushed towards the left. So this piston will be pushed towards the left. So gas will be compressed. So this is V1. The piston is pushed towards the left and new position, the pressure is increased from, obviously when the volume will decrease, pressure increase. Which law is this? Boyle's law. So this is P1 and the pressure is increased to P2 and the temperature is constant because this is the definition of Boyle's law. We need to calculate the volume too. So what is Boyle's law? P1, PV is equal to constant. So you can write P1, V1 is equal to P2 and V2, and we need to calculate V2. That will be equal to P1 V1 divided by P2. Okay, by putting the values, P1 is 1 times 10 power 5, that is atmospheric pressure, times V1. V1 is 240 cubic centimeter divided by P2, that is 1.4 times 10 power 5. I did not change cubic centimeter because you can see the volume V2 is also in cubic centimeter. So no need to change it. Okay. So when you solve it, your answer will be 170 cubic centimeter. The area of the piston in contact with the gas is 1.9 times 10 power minus 3 meters square. So this is area. Calculate the force exerted by the gas when the piston is held in the new position. So force, area, and pressure. P is equal to force over area. This is the definition of pressure. And we need to calculate force. Force is equal to pressure times area, PA. Okay, so here, what pressure we will use? Obviously, force is increased after compress the gas, so we'll use the second pressure. What was that? 1.4 times 10 power 5. This is second pressure. Times area, that is 1.9 times 10 power minus 3. And the unit of force is Newton. Units are very important, so don't forget to write the units. Okay, after using calculator, you will get 270 Newton. Question 3. The distance moved by the piston is, this is distance because this is meter. If it is meter square, so it will be area. The average force exerted, average force is always resultant force, that is 4F, 220 Newton. Calculate the mechanical work done. So it's very simple. Work done is equal to force times distance in the direction of force. So force is 220 Newton times distance is 0.036 meters. So the answer will be 7.9. And what is the unit of work done? Energy, that is joule. So just write J. Okay. Last question, last part of the question 4. Explain in terms of particles why gas can be compressed but liquid cannot. It's very simple. There is a space between the gas particles. Large space between the gas particle, distance between the gas particle is larger. So you can just write anything. So space between gas particles is greater. Because it is 1 mark, so no need to write about the liquid. So just write this line, you will get 1. Okay, question 5. There is a large puddle of water on a road. The water in the puddle evaporates. Describe how evaporation from the puddle occur. Use idea about the particle in your answers. So particle escape from the surface of the liquid, that is called evaporation. So from the surface of the liquid, so you can just write escape. You can just write particle escape from surface. You will get 1 mark. Which particle escape? Which have maximum energy, like minimum energy due to speed. So those particles which have kinetic energy or kinetic energy escape more particles. Whenever I talk kinetic energy, so it's mean speed, fast molecule. So you can just write in your own words, faster molecules, kinetic energy, escape more particles. So you will just write the factors. Second part, state and explain one change in the weather that cause faster rate of evaporation. Oh, due to weather, it's mean due to windy. When air is windy, so in that case, air temperature is higher, sunshine. So there are many reasons. Windy temperature in summer season, the evaporation rate is higher than the winter season. And particle escape, you will just copy this thing here. Particle escape from the surface and blown away. Okay, I'm not writing it, just rewrite this thing. B part, a car travel on the dry road. The driver passes the brake, presses the brake. The car travel a distance before it come to rest. The distance is called braking distance. Strain explain how the braking distance changing when the road is wet. When the road is wet, friction will be decreased. So braking distance will be increased. The car will take more time to stop. So you can just write friction decrease because the road is wet, and braking distance increase. It is 1 mark, so no need to write more detail. So this is question number 5. Question number 6. A part. Figure 6.16 shows successive crust of water wave approaching the boundary. So these lines are showing crust, and the distance between two crust is called wavelength. This is region A and this is region B. The speed of the wave in the region B is lower than the speed of the wavelength in region A, wave in the region A. On figure, draw the crest of the wave in region B. So when the speed is decreased, wavelength is also decreased. V is, okay, and V is equal to F lambda. So speed and wavelength are directly proportional to each other. So when wave is going this side, at this boundary, wave is slightly bent. Okay, let me redraw this. And the wavelength will be decreased. So you will draw four lines with the equal distance, and the distance should be less. So you can see in this case, wave is going this side, and in this case, wave is going this side. So you will just draw four lines with smaller wavelength. Crest will be getting close. State the effect that occurs as wave cross the boundary between the region. When the wave cross from one medium to another medium, this is called refraction. There are three properties: refraction, reflection, and diffraction. So this is refraction, bending of wave when it passes from one medium to another medium. Light can be total internally reflected when striking the boundary between two regions. State two conditions necessary for the total internal reflection. So first thing, speed of light in first region should be less. So I'm just writing speed of light in first region is less than speed of light in second region. So you can complete right. And what is the second condition? The second condition is angle of incidence must be greater than critical angle. Angle of incidence, I'm just writing I. You will write complete sentence. Angle of incidence must be greater than the critical angle. Okay. So this is the basic condition for total internal reflection. Last part of question 5. State, this question 5? Yeah, question 6, sorry, my bad. So last part of question 6. State two advantages of using optical fiber transmission high speed in the broadband. In the past, we use like uh, copper wires. The data rate was very slow. So you can just write high rates of data, carry large amount of data, and it is a glass. So signals pass through the speed of light in the form of light. So you can just write high rate data, or you can write fast data. Signals travel through light or with the speed of light. So you can write many things. This is question number 6. Question number 7. A circuit consists of an AC supply of two lamps. The lamps are connected in parallel. So there are two types of circuits: series circuits and parallel circuits. Draw the circuit diagram. So you have to draw the circuit diagram. So you have to draw AC supply and two lamps. So I'm drawing one lamp here. What is the symbol of lamp? You will draw the cross and circle like this. And you will draw another one because of parallel. So you will draw up and down. You will join through the wires. I'm joining through the wires. And I will take the common point. That's why this is parallel circuit. The current is divided into two or more parts. And you will not draw the cells, you will draw the AC supply. So you can draw like this. Okay, so this is lamp 1 or this is lamp 2. This is AC. So this is complete circuit. The electromotive force of AC supplied by 230 volt. So this is EMF. When connected to 230 volt supply, the resistance of the lamp is 1200 ohms. This is resistance of the lamp. Other lamp is 800. So this is R1 and this is R2. Calculate the current in the lamp 800 ohms lamp. So we will calculate the resistance. We will calculate the current in the second resistance, second lamp. So here we can use Ohm's law. V is equal to IR, or I is equal to V over R. Here, this is a parallel circuit, and in the parallel circuit, voltage across the same. Each component, like lamps, or each component, the voltage in the parallel combination is same, that is 230. And which lamp? Whose resistance is 800 ohm. So when you will calculate, that will be 0.29. What is unit of current? Ampere. Second part, calculate the energy used by the lamp, 800 ohm lamp in 5 hours. So that is kilowatt hour. This is the unit of electrical energy. So energy is equal to, what is the unit of equation of energy? V, I, and T. Because actually this equation come from uh, power. Power is equal to IV, and power is equal to energy over time. And here you can use energy is equal to PT, and P is equal to IV. So I, V, and T. So here I use this equation. Okay. So V is same, 230. Current is 0.29. We just calculated. Time. Time is 1 hour, right? So what is time in 5 hours? So 1 times 5 is 5. Divide by 1000, because it's 1000 watt. So that's why we have to divide with 1000 in this case. So answer will be 0.33 kilowatt hour. Calculate the combined resistance of the lamps in the parallel circuit. So first resistance is 1200, second resistance is 800. So what is the equation to calculate the combined resistance in parallel circuit? That is R equivalent is equal to 1 over R1 plus 1 over R2. This is the equation we use in parallel combination. So first is 1200. The second is 1 over 800. Okay. And the final resistance will be 480. And unit is missing, so you must write the unit, that is ohms. Question number 8. State what is meant by magnetic field. So what is magnetic field? Field mean region. So it's electric field or magnetic field, you always start with region. Region or space. Region in which poles of the magnet, North Pole and South Pole, poles experience a force. That region is called magnetic field. Figure 8.1 show an ammeter connected to the coil wound on the plastic cylinder. So this is a plastic cylinder and coil is wound. This is electromagnet. Trolley is placed on the curved track, passes through the cylinder. So when the trolley passes through the cylinder, so magnetic field will change in the solenoid. So this is solenoid. So EMF is induced. This is ammeter is attached across the coil. Sorry, with the coil. The trolley is released from the position if the trolley travel through the coil from right to the left. The trolley travel back from the left to right. It has low maximum speed when it travel from left to right, just like simple pendulum. Trolley will move from here, and thus it will have maximum speed here, and it will go this side. The trolley will reach at this position, and at this position the trolley move back again. So the current will produce. State why there is lower maximum speed when the trolley travel back from right. Okay, when the trolley travel back from the right, so what happened? Friction between trolley and track. So induced current will produce. The direction of current will be changed. That is opposed. You heard about the Lenz law. That is the same thing. So you can just write friction between the trolley and track. This is the easy way. Friction between trolley and track. The second you can write when the trolley move back due to induced current, it opposes the direction. That's why the speed is decreased as well. Figure 8.1 show a close up view of ammeter. What is ammeter? Which measure the currents. This is ammeter. Here you can see am ammeter, ampere meter. Okay. As a trolley enter to the coil, move to the right to left, the ammeter needle deflect left and then return to zero. State and explain any change to the deflection on ammeter as a trolley enter coil when moving back from left to right. When it moving back from left to right, direction will be left. Okay, direction will be left. So you have to write 3 points for that. Induce obviously when the trolley is moving, so induce current will be induced. Okay, so you can write uh because trolley was moving in that side, so you can write induce current will not change. Induce current direction will same. 2 points. And third point, you can write smaller current will be produced. Small, because very small magnetic field will change. Small magnetic field is change. So smaller current will induce. Okay. Question number 9. Figure 9.1 show a beam of radiation in the vacuum. The beam contain alpha, beta, and gamma radiation. So cross means the magnetic field is into the page. So the beam entered to the region where there is a strong magnetic field. The direction of the magnetic field is into the page. Okay, draw the path of alpha, beta, and gamma radiation. Why there are 2 marks for beta? Let me tell you. Because beta particles are electron, it will slightly deflect because it is very light. Alpha particle will not slightly deflect. It will take more time to deflect because alpha are the helium particles that are heavier. So alpha particles using Fleming left hand rule, alpha particles move upward. Sorry, let me make it more longer. So these are alpha particles. Beta particles are light, so it's slightly deflected. So these are beta particles. And gamma particles doesn't affect magnetic field, so they move straight. So these are gamma particles. So you have to draw these 3 lines, you will get 4 marks. Next question. B part, table 9.1, show 5 radioactive sources. The main type of radioactive radiations emitted by each source, half-life. Okay, alpha, beta, gamma. PQRST. Okay, define half-life of radioactive. What is half-life? Half-life basically is a time. Time taken, the half of nuclei of sample decay. So you can just write time taken, 1 mark, so make it short. Time taken of half of atoms decay. Decay means stop emitting radiations. Two part. Second part, the figure 9.12 show the simplified diagram of machine that produce the sheet of aluminum of constant thickness. So aluminum sheet, basically, we can check the thickness of aluminum sheet by using the beta particles, and beta particles are electrons. Okay, here you the bit this is the source in which some particles are passed, some particles are blocked. So the radiation detector is used to measure the thickness of aluminum sheet. State the most suitable radioactive in table 9.1 for the machine of 9.2. Explain why the radioactive source is more suitable and why the others is not suitable. If you talk about alpha, beta, and gamma, beta particles are stopped blocked by aluminum sheet. So beta particles can be used to check the thickness of aluminum sheet. So if you see the graph, beta particles R and S. If you see S, the half-life is very short. So we need to take the longer half-life to check the thickness. So R is correct answer. So first thing R. We will take the R. More suitable source is R because it's longer half-life. So its decay will be slow. So here you can write. I already explained. Its half-life is more. This is the first reason. Count rate. The second reason is count rate uh, changes with thickness. Okay. Uh, it's mean that count rate will not change due to half-life. Count rate will be changed. The emission of radiation will be changed due to thickness of the sheet, which we are checking. And gamma radiation and alpha radiation we cannot use. Why? Because alpha radiations, this is alpha, alpha radiations will be stopped completely, blocked completely, and gamma radiation pass all, I'm writing all gamma radiations pass through sheet. Okay. So I'm just writing the reasons why I choose R. So only the beta particles can be used. Question number 10, last question. Fill in the gaps in the description of how acceleration of model explain the formation of solar system. The planets near the sun are small and rocky. First four planets are rocky and the last four are gaseous, right? So further is gaseous. All the planets were found when the clouds, gas, and dust particle collapsed due to why they are collapsed? Because of gravitational force. Where there is a mass, there will be gravitational force. Okay. The last thing is the rotation of material in the cloud form. It's already discussed here. Acceleration disk. So it's acceleration disk. So you will get 4 marks. The time taken for light to travel moon is 1.3 seconds. Calculate the distance of the moon from the earth. Give your answer in meters. So we need to calculate the distance. It's very simple. Distance is equal to speed times time. And because this is a light year distance, so we will calculate the time is already given, so no need to write. times light year. So speed of light is 3 times 10 power 8 because we are talking about speed of light, that is 3 times 10 power 8, and the time is given, that is 1.3, and that will be 3.9. Simple. 3.9 times 10 power 8 meters. It's already meters. Okay. C part, last question. The Whirlpool galaxy, the name of the galaxy is 2.3 light years from Earth. The current value of Hubble constant is this, and you have to memorize this value as well. Calculate the speed of Whirlpool in the moving galaxy. So you need to calculate the speed. Basically, what is the relationship between the speed and distance? That is Hubble constant times distance. Okay, the distance is given, that is 2.3 times 10 power 7. So multiply this, so you will get 4.8 times 10 power 5 meters per second. That is the speed of the galaxy. So we done 10 questions, and this is a complete paper. If you have any question, you can ask in the comments. Just keep subscribe my channel, and see you in the next paper. Goodbye.